on this day, or yesterday, depending on if we're, which temporal hemisphere we're in, July 23rd, a long time ago, I was really interested in the sort of ancient metaphysical beliefs about the star Sirius, our brightest star. And they said that July 23rd was the day that the ancient Egyptians celebrated as their New Year, because that was when it was called the heliacal rising of Sirius, when it came out of being in conjunction with the sun for 70 days, and it was so symbolic because it represented the rebirth of Isis, and it was when the Nile flooded, and it was the rebirth of life and stuff like that. And I've come to learn that the heliacal rising of anything is contingent on both latitude and longitude, and probably more on latitude. So it's actually, like with a lot of things, it's not an instant of time, it's a window of time. So I know that the heliacal rising of Sirius can be anywhere from now until like probably a month from now, because I know down here, Sirius is just now coming into conjunction with the sun, but from the evening side.
Yeah, that's right. Just because we're we're in a different latitude range from Egypt, certainly, and in fact, what you're saying, Jeff, resonates with me too, because I grew up in the Northern Hemisphere, and in the Northern Hemisphere, the constellation of Orion, which is right next door to Sirius, is something you only see on winter nights, the months October to about March or April. And I was staggered when I came to Australia to find that you can see Orion virtually the whole year round, and it's because of the way, the position of the sun in the middle of the year in relation to the constellation of Orion itself. The sun is well north of the equator. Orion sits on the equator, so at the latitudes we are, even though the sun is about to rise, Orion's already above the horizon.
Yes.
And Sirius, of course, is close by there.
Astronomically,
you're absolutely right, though. Excuse me, that many ancient cultures looked at these heliacal risings to form their calendars. It's true in South America as well as Egypt, and also true here in Australia.
Yes, and we're also in there's a Maori celebration or festival in New Zealand called Matariki, which is their name for the Pleiades. And so it has the Pleiades, I think, had its kind of heliacal rising period a few weeks ago, but they're having that festival now. It's kind of like a midwinter Christmas for the Kiwis. But and then we had the heliacal rising of Venus a few weeks ago, which apparently is very important to the Mayans, as it it was being reborn as the morning star, and and shifts back and forth. And then now tell us is it pronounced syzygy?
Yeah.
Syzygy, that's one of the weirdest words in English, but tell us about that.
So syzygy is a great word, especially for Scrabble, because you've got so many high counting letters there. I haven't played Scrabble for a long time, but I was always looking out for a syzygy. It's just when bodies align, when three bodies align in the solar system. So every month we have two syzygies involving the sun and the moon, when we have new moon and full moon. Those are both examples of syzygy taking place. So it's an unusual word for a pretty simple phenomenon.
Yes, it's geometrical. Do you know the etymological root of that word?
I don't know. Probably wouldn't be hard to find out, but I'm not sure about the origin of that word.
Yes, that's okay.
It's such an unusual word. It doesn't,
Yes, it
doesn't have that much to do with other things.
It doesn't.
That's why.
Exactly. It does.
Synonyms and not simultaneous. Starts SI, but that kind of thing. So it's probably relating to things being in the right alignment.
It almost sounds like
I'm making this up as I go.
Exactly. Well, no, but that's good. I like that. It's creative, like the universe. What if it was somebody's name, Dr. Syzygy? Professor Hans Syzygy from Romania or something like that. Well, now let me ask you about this. I also know that just in either now or in the past couple of days, and again, we're talking about windows of time, where there's things are moving. We've had what they call the opposition of Jupiter and Saturn. And that's where, isn't that where the planets are opposite from the sun, on the opposite side of the sun from the Earth, right?
Yeah, so that's a sort of specialized case of syzygy, because that's exactly right. We call it opposition because for that excellent reason that the planet is opposite the sun in the sky.
Yes.
Yes. So, as far as the outer planets are concerned, the inner planets never go through opposition. So Mercury and Venus are always on the sunward side of the sky.
Yes.
Simply because they're in orbits that are nearer to the sun than ours is. But the outer planets all go through opposition at some time during the year, and it's always spectacular when Jupiter and Saturn are in opposition because they're particularly bright. Mars likewise is bright when it's at opposition.
Yes.
And of course the other consequence of this, Jeff, is that when planets are at opposition, they're at their nearest. So because the Earth and the planet are on the same side of the Sun, so you've got you're at the nearest position to the planet, which is why Jupiter's worth a look through binoculars or a small telescope at the moment.
Yes,
Some of the moons of Jupiter.
I've been doing that a lot lately. They call them the Galilean moons, right? The 4 bright ones.
Yeah, that's right. That's correct.
Well, now the opposite of opposition was when it's in conjunction, right? When it's really close. And this is just kind of like a line of sight kind of thing. But now I wanted to ask you about 2 other words that are perihelion, when a body is at its closest approach to the sun. And then it's APH, and I never knew if it's pronounced with an F sound. Is it aphelion or aphelion?
Yeah, it's usually aphelion.
Aphelion.
Separate the two.
Yeah.
The two consonants.
I think this is the first time I've ever tried to pronounce it. But that's the proximity to the sun. But what do you call? Is there a word for when an object is having its closest approach to the Earth? Could it be peritarian? Or
good guess.
apterian?
It's not quite right. It's we take I guess it's the Greek root. So it's perigee. Comes from things like geology.
I get it. Well, because they used to talk about that for rockets, the perigee of a rocket flight.
Yeah, exactly.
An apogee.
To the Earth. Apogee is the furthest point from the Earth.
Because in my mind, that only related to something that was coming off the Earth, up in the sky and then back down. So, but you also use that with respect to like planets and comets and stuff.
Yeah. For natural objects. I
see. Well, now we're getting to one of the coolest things I wanted to ask you about, this brilliant comet Neowise 2020 F3 that's putting on such an amazing show. And I've been following it for a long time, and it was very interesting that when I first became aware of it, it was actually in the constellation Taurus, near the Pleiades, not far from the 2 radiants of the Taurid meteor stream showers. And as I've become very acutely aware since you first told me about Victor Klube and Bill Napier, and the legendary comet ENCKE, which my friends from Germany said that's actually pronounced Anka. It's a German name.
They anglicize it to Enka, but
Enka. Yeah. But I really want to. When we did our first show 2 or 3 years ago, you told me about Victor Klube and Bill Napier, and I never heard of them at the time, or maybe had seen their name. And you studied under them, right?
I did. Yeah, I worked with Victor Klube particularly. Bill was a colleague. This was in my days at the Royal Observatory, Edinburgh. But Victor and I were working on something quite different. We were working on the motions of stars within our own galaxy. And I was kind of his student, although in an informal way. I was his research assistant, really. But then some of the work that we did together found its way into my PhD thesis. So we were interested in the way the galaxy moves. But that kind of tied in with his subsequent work with Bill Napier on the way objects move within the solar system, and whether there is evidence that we can find today that there is some disturbance by objects in our own galaxy of objects in the solar system. And of course what I'm thinking of is comets in the Oort cloud. These are icy bodies which way out in the depths of space don't really do very much. They're just the leftover remains of the formation of the solar system. But the hypothesis that Klub and Napier put together was that as the Sun and its family of planets and things like the Oort cloud, which is part of that family, as they move around the centre of our galaxy, they will occasionally come close to gravitating objects. They were thinking in particular of things called giant molecular clouds, which could exert enough gravitational influence on the Oort cloud to send objects in towards the inner solar system, where they would increase the risk of collision with the Earth. And so Comet Encke is thought to be a comet that may well have been shaken up by passage near a giant molecular cloud.
Wow. That makes me think of
debris falling on the Earth. Sorry, Jeff, go on.
Oh, no, that's okay. I could listen to you talk about that all day. It made me think of a Fred Hoyle novel called The Black Cloud.
Yeah.
Wow, and that is very, very interesting. Well, in one of the papers that you were kind enough to send me, I've been able to get in touch with both Victor Klub and Bill Napier, and they have a concept called episodic bombardment, which I think it's trying to map out periodicities in as maybe the solar system moves within are we in what they call the Sagittarius arm of the galaxy, or something like that?
Yeah, apparently we are. We're look, this is a field that changes fairly rapidly.
Yes.
In the exact geography of where we are located. We used to be on the Orion spur, in the Orion spur of the Sagittarius arm, and I think that's probably what astronomers think of today when we think of our location in the galaxy.
Yes, it's very interesting when you try to actually visualize what it is that we're attempting to do from where we are. We're trying to create a picture of what the galaxy looks like if you're not in the galaxy, without leaving the galaxy.
Yeah, it's a tough ask, and I'm really impressed with the work that's been done on essentially figuring out what our galaxy looks like,
yes,
like from the outside. That actually goes back, Jeff, to the period shortly after the Second World War, when it was realized that cold hydrogen can emit a signal in the radio frequency spectrum. And so Dutch radio astronomers in particular got very excited about this, realized that the spiral arms of our galaxy are rich in hydrogen gas, in cold hydrogen, and used radio telescopes to map out where that cold hydrogen was. And that was the first concrete evidence we had of spiral arms within our own galaxy. Because, as you say, when we're immersed in the disk of the galaxy, and it's a pretty dusty disk as well, it's not that clean, it's got a lot of dust in it, which limits our view of even the stars in the immediate neighbourhood. Most of the stars we can see in the Milky Way are within 1,000 light years.
Yes.
And our galaxy is about 100,000 light years across, so
yes,
you're really only seeing a very short distance.
Yes.
But with the radio waves, you can penetrate that dust, and more recently that's been done with infrared astronomy.
Yes.
So we've now got a pretty good idea of what our galaxy would look like if ever we could get out of it.
Well, how many people, say, like if we picked 100 people at random and showed them a photograph of people, like if you typically Google the Milky Way and it shows you the photo, it goes like, this is our galaxy and it's a spiral or blah, blah, blah. How many people would not automatically know that wasn't a photo taken from somewhere?
Yeah, exactly.
You know what I'm saying? Because it's like one of those...
in fact, I guess it's because we can see other galaxies,
yes,
that we can, to some extent, fill in the gaps in what our galaxy looks like. One thing, forgive me if I go down this path, Jeff.
That's all right.
This is such a great analogy or illustration that I try and throw it in wherever I can. If you imagine a picture of our own galaxy, exactly as you've described, something like a photograph that you've got on a computer screen, this thing 100,000 light years across, imagine that picture, and then imagine it, the same picture, but blown up to be the size of the Earth. So you've now got a picture of our galaxy that is 12,500 kilometers across.
Yes.
The distance from the Sun to the Earth on that scale is 2 millimeters.
That's all.
So, yeah.
Oh my God! Wow.
Our galaxy.
Wow, that's a great metaphor or analogy. But it gave me an image in my mind very clearly. 2 millimeters out of 12,000 kilometers.
Yeah.
Wow.
So the galaxy is a big place, and what we see of it from our vantage point on Earth, at least in visible light, is quite local.
Yes. Well, now the large and small Magellanic clouds? They're the closest ones, right? And they're how far on that scale? How far away would they be? They're what, 500,000 light years or something like that?
Yeah, they're actually they wouldn't be that far away because our galaxy is about 100,000 light years across. The large cloud is 165,000 light years.
Oh, is that all?
So it's not much more than the diameter of the Earth.
Very interesting. So they're close.
So, Jeff, I'm just going to interrupt us for a second.
Yes. No, that's fine.
There's somebody outside making a noise.
I hear it's like a little.
I'm also going to grab my headset.
That's okay. Take it. Yes, it's making a little ringing sound.
Yeah, that's right. It's
no, that's fine. That's fine.
We live next door to a vet, and there's a dog groomer who hangs around the vet.
Oh my God!
He's trying a dog at the moment.
Oh, that's all right. No, take your time. Make a cup of coffee if you want to.
Yeah, something like that. Just hang on a second.
Okay.
And I'll be back with you in a very short time.
No worries.
I'll leave you with the cat.
Okay.
Made his contribution.
What's its name? What's the kitty's name? Meow. Meow. Meow.
Just one minute.
Meow.
I've got to be careful here because there is a gotcha that I've discovered before. We used to do our podcasts under Skype, and there's all kinds of things that can go wrong in the settings. So I'm plugging the headphones in.
Okay.
I have to twiddle the controls just to make sure I can hear you. Okay, all faithful headphones. Are you speaking, Jeff?
Now I am. How's that?
Yeah, that's better.
Oh, good. And yes. Okay. Are you ready?
Yeah, that's much better. Back online. Sorry about that.
Oh no, that's all right. That's all right. It's very interesting. The Victor Klube and Bill Napier are, to me, the legendary comet astronomers. And it was from you that I first heard about them. And since then, I've learned a lot. I've read a lot of their articles, and Bill and I were able to correspond quite a bit until he had to say, like, Jeff, I'd love to keep doing this every day, but I've got so many other pressing things, like his wife was ill and he's writing books and articles and blah blah blah. And then Victor thanked me for his painted rock. They both got their painted rocks, and and Victor thanked me, what I did, the rocks I painted had pictures of a comet in the sky in the Milky Way, but with dolphins swimming.
Yeah.
And Victor said something about that my rock proved that something about Zechariah Sitchin, or that something about there, if you look at the Sumerian thing, there was a being called, it looks like Anka, but it's Enki. Enki, and I'm not even sure what it was, and I haven't got him to email me back yet, because I was hoping that I might entice him to do a radio show with me or something like that. But see, but right around the time I was getting in touch with him is when the coronavirus thing hit, so that's kind of thrown a wrench in everything. But basically, correct me if I'm wrong, you said in our first interview that it was their research that kind of really it not only laid the foundation for the whole sort of cometary impact thing as being a major driver in the progression of life on Earth and things like that, but also that they communicated with the Alvarez team a year or two in advance of when they published their paper that kind of, like, to use your expression, kind of stole their thunder about that whole thing. But I've come to see that really the Alvarez work is really just looking at one instance, whereas their Klub and Napier are talking about an astronomically bigger picture of the whole motion of the solar system within the galaxy, and the episodic bombardment scenario, and how there may be periodicities that exist that we may or may not be able to understand. But is that, tell us about that. You said that Klub and Napier, just out of the goodness of their heart, shared their findings with these guys.
I'd be interested to know whether Victor Klub and Bill Napier have commented to you on that stuff at all, because certainly when this was happening, they were extremely upset. They did feel that as I said, that Luis Alvarez and his son Walter had stolen their thunder to some extent, because Luis and Alvarez, exactly as you've said, they were studying the iridium layer at the Cretaceous-Tertiary boundary and were looking for a cosmic explanation for that. And the framework that Victor and Bill had really provided exactly that. But I agree with you also that the Klub and Napier were really looking at the bigger picture, the idea of episodic bombardments. They wrote about it in their book, The Cosmic Serpent. I think they wrote about it subsequent to that. I've got a little anecdote, though, that I can add to this, Jeff, that comes, and it's something that I didn't know when you and I last spoke. And that is that I have a good friend who is a volcanologist at Macquarie University here in Sydney. I got to know her through another volcanologist who I know very well, who's actually based in the United Kingdom, a man by the name of Nick Petford. He's also the Vice-Chancellor of Northampton University, so he's in a very elevated position, but he's mad on volcanoes, so he's come with us on some of our tours to Hawaii and to Iceland, places which are interesting for their volcanism.
Oh my God.
For the astronomy. Okay, so I met this volcanologist in Macquarie University, and it turns out that she was a student of Walter Alvarez.
Really?
So she has the story from the Alvarez side that I saw from the Klub and Napier side, on the other side of the Atlantic.
Will you tell us that? Can you tell us that? Will you tell us that now?
We haven't done it yet, but one day we're going to get together and compare notes on that, and perhaps write a little article about it, because it is such an interesting era of astronomical history. It was the start of our understanding that, yes, perhaps there have been species extinctions on Earth which have been caused by the impact of extraterrestrial bodies. It was a very exciting time, with this little bit of tension in it as well. I'm delighted to say that there's absolutely no tension between me and my volcanologist friend, but we can probably piece together some of the history of what was going on the two sides of the Atlantic when this work was being done.
That is so cool. This makes me think of how Bill Bryson tells the stories, like in A Brief History of Everything.
Yes.
But can you, in a nutshell, tell us the story that she shared with you? What they thought, what their take on it was?
Look, we haven't got into that sort of detail, but she does know that it was a very exciting period of Walter's career.
Yes.
So she would have been a student of Walter's, more recently than all that work, which was done basically in the late 1970s, early 1980s.
Yes.
I think she was a student during the 1980s.
Well, so was Walter the geologist or the Manhattan Project physicist?
He was the geologist.
Okay.
Lewis was the physicist. Yeah, that's right. He was involved with the Manhattan Project.
Yes, that's very interesting. But so to me, the most important thing about all this comet stuff is that it's not purely academic, and it's not a thing of the past. As a lot of this stuff, we forget that anything that's happened in the past, it may not have happened for a long time, but we must remember that a lot of this stuff can still happen again at any time.
Exactly.
our whole notion of time frames and that kind of thing. But to me, that's the real important reason about the work of Kluber-Napier, because they're providing a framework that might actually allow a degree of predictive, or at least kind of an acknowledgement of, because when you're talking about these clouds of dust that prevent a lot of visibility. There was a team of astronomers from the Czech Republic about 3 or 4 years ago that I could find their paper and send it to you, but they're talking about how they reckon that part of the Torrid stream objects, related to the Anka supercomet, that there's a lot of fragments out there that are a lot larger than we might think, but they're obscured by clouds of dust and sort of behind other objects and stuff like that. And they reckon that there's a much higher probability of the Earth encountering, something of significant size than is commonly given credence to. And just the fact that we don't know. And when you read about all these what they call PHAs, potentially hazardous asteroids, and all these things that are ones that come relatively close to the Earth, but they were only discovered as it was doing that, or even after it just swooped past us. After our close encounter, that's when we go, oh, hey, this thing exists. And so, these are all small and inconsequential. But if there is a big one, we probably won't even see it coming, right?
Yeah, I'd be interested to see that paper.
Yes, I'll send it to you.
Because, a lot of the people I kind of know and work with are engaged with things like near-Earth asteroid surveys.
Yes.
With the, as you know, the statistics are that we believe we now know of 95% of all potentially hazardous objects that are bigger than a kilometre. Now, a kilometre is big enough to do serious damage to the Earth, so you really want to be looking for things bigger than 10 metres or 100 metres or something like that. And now the imperative for discovering these things has shifted to objects about 140, I think, is the number of metres across. And the good thing, it's a sort of two-edged sword here. The big objects are the ones that do the most damage, but they are the easiest to find.
Yes.
Because they are highly reflective, not needing to be really all that highly reflective. Many asteroids are quite dark intrinsically, but once you've got objects that are big enough, to do significant damage, then their brightness as they're illuminated by sunlight is enough to make them detectable. And this whole business is going to change within the next 2 years when the Vera C. Rubin telescope comes online. I don't know whether you're familiar with this. It's an 8-meter class telescope. Until about 6 months ago, it was called the LSST, the Large Synoptic Survey Telescope, which will survey the entire sky every week, more or less. And in doing that, we will be able to detect objects in the solar system which are really very small. It's going to certainly help in the search for potentially hazardous asteroids.
Wow! And so it's
but I would be interested to see the paper.
Yes.
I'm never a great fan of people who say there's one thing's hiding behind another.
Things
tend to work.
That's my own oversimplification. But I'll send you that article. So that telescope is dedicated specifically for this purpose.
No, it's dedicated to transient astronomy. Which, I mean, things that come and go.
Yes.
Of course, potentially hazardous asteroids fall exactly into that bucket, so it will find them.
Yes.
But it's also looking for new astrophysical phenomena, of which we now know an increasing number are sort of things that come and go in the night. One of the biggest mysteries that faces astronomers at the moment is the nature of things called fast radio bursts. These are bursts of radio radiation, which, as their name implies, are very fast. They last for no longer than about 5 milliseconds. And we're really interested to understand what these things are telling us about.
Yes, it's
so transient astronomy is the kind of future of astronomy.
Yes.
It includes anything that's moving as well as anything that comes and goes.
And technically, that's all right. Technically, transient astronomy would be about anything that doesn't last forever, right?
Exactly.
No, I'm just kidding. No, but look, this reminded me. I saw a photo last week of a giant, kind of a fat telescope that's in Exmouth, and it was called something that looks for. I forget what it was called. I saved the photo of it to ask you about, but I forget what it's called. But it sounded like it's called the Space Surveillance Telescope, the SST. But it looked like it almost might be kind of like a military thing.
I think it is. I think that it's probably right. It's what is called space situational awareness.
Yes, yes.
It's all about finding out what your neighbouring satellites are doing. So it's particularly designed, I think, for objects in Earth orbit rather than more distant objects.
I see. Well, I want to ask you about satellites, but not quite yet. The Tunguska event on June 30th, 1908. Now, when I was, I'll mention Duncan Steele's name because I interviewed him in Nelson, and he's like a leading expert on sort of like the mechanical aspects of all the comets and asteroids and orbits and eclipses and stuff like that. And we were talking about how that they reckon that it didn't actually strike the ground, that it somehow exploded as an airburst, and it leveled like thousands of kilometers of forest and created. I read in reading. I watched an Arthur C. Clarke episode of his TV show where he talked about that, and they were talking about how it created weird auroral displays at the geomagnetic conjugate point on the opposite side of the Earth when that happened. And that sort of keyed them off when, just like when they did the first atomic explosion, it created weird atmospheric stuff on the exact opposite side of the Earth because of the magnetic fields and stuff. But they were reckoning, what did they say that the size was of the Tunguska object? Was it like 150 meters or something like that?
Yeah, maybe even smaller than that.
Smaller? Oh my God.
You're absolutely right. Almost for every individual researcher, there's a different theory about the Tunguska event. The one I read about most recently was the possibility that it was a grazing incidence object, an object that entered the atmosphere, exploded with an airburst that was near enough to the ground to flatten those 4,000 square kilometers of forest, Siberian forest, but then just continued on its way.
For real? So what, you mean like only a piece of it?
Continued on its way. So it was, coming in at such a shallow angle.
Yes.
It almost bounced off the atmosphere.
It skipped. It was a skipping stone.
The latest, I think, of the theories that, that's being bandied around about that.
Yes.
I'm perhaps an interested observer in that rather than in any sense an expert.
Well,
I don't back one theory or another.
Exactly. Well, that's
they all rely on really fairly frugal shreds of evidence.
I was going to say flimsy.
I quite like the idea of an object sort of bouncing off the atmosphere and just doing a bit of an explosion above Siberia before it left us.
Yes, very interesting. Well, look, let's talk about This relates to the molecular cloud idea, which is very interesting. And you don't really think of a giant molecular cloud as having enough mass to be a gravitational effect, but that's just that's a limitation just in my own mind. But you've got these clouds of stuff, and they might be moving, and then as we're moving, and then the solar system might pass through or within different density levels of all different kinds of stuff left over from the creation of the universe, or it might be evolving in its own way. And so what I'm getting to is what they call the Panspermia theory, that Hoyle and I never can pronounce the Indian dude's name.
Vikram
Singh. Yes.
Chandra Vikram Singh.
Yes. Did you know him? Do you know those guys?
Yeah. Well, I doubt that Chandra would remember me, but I did interact with him about probably 30 years ago.
Yes.
When this was while Fred Hoyle was still alive.
Yes.
Were doing sort of almost like lecture tours among academic institutions to try and sell their idea of panspermia. So I met them both. Chandra has a brother called Dayal Vikram Singh,
okay,
who works here in the ANU in Canberra. But Chandra, I think, now works at the University of Buckinghamshire in England.
Yes. Is his brother also an astronomer?
He is an astronomer, but not in any sense an astrobiologist, which I guess is what Chandra would call himself today.
Yes, well, no.
Dayal's work, if I remember rightly, was much more theoretical and involved. I can't remember actually. I think he worked on galaxies and galactic structure. Very interesting.
Well, now what do you think about tell us about the Panspermia hypothesis.
So it's interesting enough to, I think, still cause a bit of excitement among astrobiologists. I think Hoyle and Vikram Singh, and we're now going back actually more than 30 years. It's more like 50 years probably, 40 or 50 years. Their work was fairly specific. They were, they pointed to outbreaks of influenza that were in geographically very remote places with no evidence of any communication between individuals that would cause the influenza to spread. And so their hypothesis was that things like viruses are actually moving around through interplanetary space, having been formed in molecular clouds, probably, maybe in the giant molecular cloud that gave birth to the solar system, because these things are big enough to have many, many families of solar systems within them.
Yes.
They are star formation regions usually.
Wow.
So the idea was that there would have been, molecular activity that may have given rise to viruses, which then found their way onto the Earth, drifting down through the atmosphere and infecting people and causing this same flu virus to appear in different places. I think that has been fairly well and truly scotched, that idea.
Yes.
But it is certainly true that the building blocks of living organisms are commonly found now in comets, as well as in giant molecular clouds, and indeed in some of the outer atmospheres of some stars. So many of these carbon-containing molecules, which are the things that we are made of, have their origins in interplanetary space. So there is, the panspermia theory as it was originally developed, I think, is still viewed with quite a lot of skepticism.
Yes.
But there is enough about it that interests astrobiologists.
Yes.
Yes, there is still the possibility that maybe life on Earth came from Mars or something of that sort.
Well, yes.
We have basically the biomolecules coming able to survive the rigors of space.
Yes. And there's a lot that we don't know. There could be stuff here. There could be stuff here that's an integral part of life that we just don't know. We haven't discovered it yet, or it might be outside the range of our perception. But remember a brilliant science fiction book and movie called The Andromeda Strain by Michael Crichton?
Yes, I don't think I ever read it.
Well, but it's really good. It's really good. But The Andromeda Strain was it was kind of like they thought it was a life form that got brought back on a satellite that they had sent out specifically for that purpose, called Scoop, to try to find organisms from space. And it came back, and it started killing all these people in the town, and they isolated it at this underground facility that was designed to study something like that. And they studied it, and guess what they found? That it was reproducing, but it had no amino acids.
Okay.
It was a crystal.
Yeah.
It was a crystalline life form.
Crystalline life.
Yes, and that could so I mean if you look at the border, if you look at what we actually mean when we say life, it's supposed to fulfill certain criteria. One of them is the ability to reproduce, to heal, and to self-replication and stuff like that. But let's talk about Mars.
You're absolutely right. Just going back a point there.
Yes, no,
Jeff,
please do.
There really is no adequate definition of what a living organism is. And that, in a way, that whole thing underpins astrobiology. What's the point of going and looking for life out there in the universe if you don't know what it is?
Well, if you can't even recognize it here.
Specialists have got different definitions, which are interesting in their own right. I think you were just mentioning there, perhaps the common definition is that a living organism is a self-sustaining, self-replicating organism capable of Darwinian evolution, which is, but the trouble is there's some machines that can do that kind of thing, which you wouldn't call living organisms.
Exactly.
So a couple of colleagues of mine have different definitions. One, Paul, sorry, his name's on the tip of my tongue, that's ridiculous. It'll come to me in a second.
That's all right.
One colleague is very keen on the idea that a living organism is something that reprocesses information, and that is slightly strange, but
it's a Bill Gates definition.
Is a possible viable definition. And then then there's Charlie Lineweaver, who, I don't know whether you've spoken to Charlie, he's at ANU.
No.
He thinks life is basically any highly out of equilibrium system.
That makes sense.
Yeah, which is another definition.
That relates with Ilya Prigoghine's idea of self-organizing systems, and also the Gaian James Lovelock, back before he went off the deep end, his Gaia hypothesis talked about how the atmosphere of the Earth is in a thermodynamic disequilibrium that is only able to be maintained in something that's alive, because anything that's not alive tends towards a thermodynamic equilibrium,
Exactly,
and that kind of thing. So you can look at it from an information theory perspective, and there's the whole idea of solid state intelligence, AI, and all that stuff based on silicon rather than carbon, and a lot of we're getting into the realm of science fiction here, but I think that good science fiction has always been firmly grounded in science. And so, and so, isn't it funny to me, with all the hysteria about climate change and the misunderstandings about carbon dioxide and stuff like that, and only to have that eclipsed by further misunderstandings about microbes and viruses, and all that different kind of stuff. But that I always thought it was hilarious that the atmosphere of Mars is like 95% carbon dioxide. And so a lot of people, I mean, isn't that correct? It's almost exclusively carbon dioxide.
Let me check that, because I thought it was mostly nitrogen, but I might be wrong there.
I think the atmosphere of Jupiter is mostly nitrogen.
So,
see, that's another interesting one to talk about. I'm pretty sure Mars is like 95% carbon dioxide. So they say. I haven't been there myself.
Yeah, no, you're quite right. That's the elemental composition, hang on, of the atmosphere. Yeah, okay. So, much different from ours. All right, so you're right. So nitrogen is less than 2%.
Yes.
So thank you very much, Jeff. I've learned something here.
Well, but it's easy to get confused.
Probably something I knew but forgot.
Yeah. But the nitrogen thing is very interesting. If you think about, that's the dominant gas in our atmosphere, yet we somehow think that it doesn't even matter for animals, but it's essential for plants. But they can't really get it from the air. They've got to get it through the soil chemicals and stuff like that. And may I give you a little interesting footnote here? There's a scientist, his name was Frederick Jeunemann, Jeuneman, and he was a professional chemist, and he edited this journal it was a journal by the American Chemical Society or some kind of big industrial organization, but he wrote a regular column where he went on all these very interesting forays into all this different kind of freaky scientific stuff. And one of his little book that he actually got is called Rapture of the Deep. It's about the effects that ocean divers have from breathing a lot of nitrogen. It creates kind of like a hallucinogenic kind of effect, and people lose touch with reality and stuff like that. And so he reckoned that because of the massive nitrogen content of our atmosphere, that humanity as a whole is kind of in a permanent state of low-grade nitrogen narcosis. Which is funny. And then also another one of his ideas, I mean, he's not passing this off as science, but he's saying, like, think about this. And another one of his ideas was that the possibility that things like a supernova blast hitting us, or maybe a coronal mass ejection of really significant size, or a galactic core burst, or some kind of energetic bombardments hitting the Earth might have such an intense energetic capacity that they actually reset the radioactive decay rate of all the elements. They reset all that at an atomic level, and thereby rendering anything we think of about geological time as being inaccurate. Because, like with the thing of radiocarbon dating and all that, and so but I'll even send you the little PDF of his book. You might be interested in it stimulates some interesting thought. But thinking about the amount of nitrogen in our atmosphere, and the how little carbon dioxide there is, but how big of a deal it's been made to be, and how big of a deal it is for the plant kingdom. But then how much of there is on Mars? But do you reckon that we might find life on Mars? Because, correct me if I'm wrong, Emily Lakdawala, when I met her, one of her biggest things that she shared was the amount of water that is believed to exist in our solar system on almost every planet and almost on every moon, except for, I believe, she said Venus is the only body we know that doesn't have any water.
Look, it's certainly true that water is commonplace throughout the solar system, including Mars. Most of Mars's water is now frozen, but there's enough water just in the southern polar cap of Mars. The ice cap in the south pole of Mars, if that was thawed out, there's enough to flood the whole planet to a depth of about 11 meters.
Really?
The enormous amount of water.
Wow.
And some of it's still liquid as well. There's really good evidence that there's a body of water actually within that southern polar cap, in which the pressure of the overlying ice and probably perchlorates, which are kind of natural antifreezes, chemical antifreezes, they might well be keeping that water liquid. And of course, water always excites astrobiologists because everywhere we find water on Earth, we find living organisms.
And what about water itself? What about water itself as a living thing?
Sorry, water is a living thing?
Yes. I mean, if you think about the ocean.
Yeah, look, that's an extension of the definition of life that I think is probably valid, but one that I'd be uncomfortable with to talk about in terms of astrobiology.
Yeah, no, that's okay. But we don't have to. You don't have to restrain yourself to the limits of your profession. We're just talking as friends. But so now, what are your thoughts about Mars? Mars has loomed huge in our imagination. Men from Mars and going to Mars and all this stuff. And there was the what was his name, Percival Lowell, that was sure that the lines he was seeing was canals that were artificial canals, and then they figured out that wasn't true. But do you reckon that at some point that all that water on Mars might have been liquid and it might have been covered in a planetary ocean, possibly like Uranus or Neptune might be?
It's unlikely that it was planetary in extent, Jeff, but all the evidence points to there having been large bodies of water, particularly in Mars's northern hemisphere, which is flat and fairly devoid of craters. So Mars's atmosphere must at one time have had enough carbon dioxide in it that it acted as a workable greenhouse gas, because the climate must have been very similar to what we experience now on Earth, with an average temperature above zero.
Yes.
The geological evidence for these oceans is very strong, both the geomorphology, the way things look, because you find oceans is perhaps the wrong word. Seas, maybe an ocean, definitely lakes, but seas is perhaps the safest word to use.
Yes.
You find all the geological features associated with bodies of water, like cliffs, and actually there are places where there are sea stacks. There are estuaries. There's beaches. All of the things that we associate with water erosion on Earth are found on Mars. But the big question, so it's pretty well generally accepted that maybe 4 billion years ago Mars was warm and wet. It had a similar climate to ours. What's not really well established is how long that water lasted. Was it large bodies of water that lasted for tens or hundreds of millions of years, or was it bodies of water that maybe only lasted hundreds of thousands or a million years or so?
It would have to be long enough to create those geological features that don't happen overnight. But
that's right.
The big looming question to me in the whole paradigm of climate change and all that is like, well, how did Mars, if it was like that, what were the driving factors in it not being like that now?
It's too small. The best guess as to Mars's evolution is that because it's only half the diameter of the Earth, its core cooled much more rapidly than the Earth's core has done, and that actually basically prevented plate tectonics from continuing. It's likely that Mars did have plate tectonics very early in its history.
Yes.
And the reason for that is that you find Mars has virtually no magnetic field, but you can find traces of magnetism that seem to, they seem to map out lines on the surface of Mars, which may be tectonic boundaries.
Wow.
Fossilized tectonic boundaries.
Very interesting.
So Mars's structure, unlike the Earth's, in which the crust is moving around all the time, Mars's structure is basically like an orange. It's just a solid skin. That's one reason why its volcanoes were able to to grow to be the biggest in the solar system, because they were above a hotspot, a bit like the Hawaiian Islands are on Earth. But whereas the Hawaiian Islands have been moving over the hotspot, which is why you've got a chain of islands,
yes,
all volcanic in origin.
The conveyor.
Mars, the hotspot, was always under the same point on the crust because there's no plate tectonics, and so this thing just blasts away for millions of years probably, and becoming the largest volcanic structures in the solar system.
Is that Nix Olympica?
So it's probably that caused the cooling that then led to the loss of atmospheric carbon dioxide.
Yes. So does Mars not believe to have a molten core like they think we do?
Sorry, you broke up in that bit. I didn't hear the question there, Jeff.
Is Mars not believed to have the molten core that we have?
That's a question that's still in the process of being answered, and it's actually one of the reasons why the InSight lander was sent to Mars. I think it was back in 2017. InSight is modelled on the Phoenix spacecraft, which sampled the permafrost on Mars in 2012. It's in the sense that it's just a platform that sits on the surface and doesn't go anywhere. Two big experiments on board. One is the seismological experiment looking for Mars quakes, and if you can pick up Mars quakes, and indeed they've done that already, you can hope to gain some insight into the inner structure of Mars. But the other experiment, which was to lower essentially a thermometer down into the subsurface soil and rock of Mars, that's struck problems because the device that was supposed to drive this thing into the surface has not actually done that. It's only got down, something like a foot or thereabouts, rather than being buried deep down under the surface of Mars.
Yes.
So the idea of that thermometer was to measure the heat flow from the centre of Mars without any contamination by radiant heat from the sun. That's why it needed to be buried.
Yes.
But so far we don't have answers on that. So I think the jury is still out on the core of Mars as to whether it's molten. Good man.
There's two. Yeah. No. Thanks for your time. There's two more things I wanted to ask you about. One is about Mars and the issue of contaminating Mars or other places with stuff that we might bring there purposefully or accidentally, and what Carl Sagan had to say. And you mentioned some kind of a protocol or something that I had never heard of. And then also wanted to touch on the dark sky initiatives and the thing with the artificial light and the thing of the Starlink satellites, and astronomers are kind of up in arms about that. And I just saw a thing today about this. China has a fishing fleet of about 2,500 mega trawlers. They make a regular Australian trawling ship look like a little fishing boat, and they've got these giant banks of spotlights like from a football stadium that they light up the whole ocean at night to make all the fish come up. Yet just another form of light pollution. But so do you reckon you're not a fan of colonization?
Not at all. I mean, so just going back to the protocols that you mentioned, Jeff,
yes.
What they are, these were laid down actually very early in the space age. They were set down by COSPAR, the Committee for Space Research, and they're called the Planetary Protection Rules. There are different categories of sterilization needed for a spacecraft, depending on what it's doing. And so the category 1, I think it is, which is the lowest, covers things that are going to places like Mercury or the Sun, where there will be no likelihood of any kind of contamination by terrestrial microbes, because the whole premise of this is that microbial life from Earth can actually survive being in space. We know that from experiments that have been done on the International Space Station. And it was kind of guessed beforehand that would be the case. So microbes can get from one place to another on a spacecraft, and so that is why these planetary protection rules exist. There are two different categories: forward contamination, which is us taking our own microbial life to other planets. Backward contamination is the opposite of that. It's bringing stuff back from somewhere like Mars that might have biological material on it, although that seems unlikely, but it's something that can't be ruled out, so it's built into the planetary protection rules. The most stringent of all the planetary protection categories is category 4C, which relates to